Okay, let's finish up checkpoint number 3. Make sure that your name's on here and make sure you write the relationship. So we've got a triangle, all the angles in a triangle, triangle sum. Angles sum 280 degrees in a triangle. Always, any triangle, this is going to work. So that means, let's do like that. Oh, that's better. That means that these 3 angles are going to add up to 180. So I'm going to skip writing all 3 of these out and go straight to combining like terms. Let's see, maybe even turn this one. Oh, that's much better. So 2m plus 1m plus 1m, that's going to be 4m. Negative 3 and positive 8, that's going to be positive 5, plus 6 is 11. So 4m plus 11 is 180. Subtract 11 from each side. So 4m equals, let's see, 169, and then divide both sides by 4. Opposite of multiplication is division. So that's going to be a decimal. That's going to be 42 1/4, and we can just leave it like that. Okay, number 10, we have an isosceles triangle. Now you may not know it's an isosceles triangle, but when these 2 angles are equal, like we said in the first homework video, then when the 2 sides are equal, then the 2 base angles are going to be equal. So if they give you that the angles are equal, the converse is also true, that, let's just add that relationship. So base angles in an isosceles triangle are congruent. That comes up a lot. So make sure that you are understanding this. So if these 2 angles are congruent, I know that this is going to be an isosceles triangle, and 3x plus 13 is going to be equal to 5x plus 2. X is on both sides. Get rid of the smaller one. So 13 equals 2x plus 2. Subtract 2 from each side. Divide by 2. There we go. Number 11, we have parallel lines cut by 2 transversals. So let's look at just one thing I like to do. Let's see, do I have a card or something? I like to cover up one of the transversals so that I am just focusing on these 2 lines. In fact, I'm going to go ahead and extend that transversal, and that should look like some of the things we were doing in class. You've got your intersecting lines. Let's draw circles. If these lines are parallel, these 4 angles are going to match these 4 angles. So I know that this angle right here is going to be the same as this angle right here. Those are corresponding angles. So our relationship is if parallel lines are cut by a transversal, corresponding angles are congruent. So this angle is going to be 110. Now looking at this intersection over here, so I'm going to cover up this, and let's just extend this, extend this. So really we don't even need to worry about these angles up here. Let's go ahead and draw our circle. That these 2 angles together are going to add up to 180. Now some of you might say, well, I know that this angle is 140 up here, so I'm going to do 360 minus these 2 angles, 280, and then get the answer and divide by 2. That works. Or you can say, I know this is a half circle. I know these are going to add up to 180, so 180 minus 140 is 40. So this angle, let me zoom in a little. This angle is 40 degrees right here. And then I know that all three angles in a triangle, so let's see, that was linear pair. Linear pairs are supplementary. Maybe put half circle in parentheses. And then I know that all three angles in a triangle add up to 180. So the last relationship I'm going to use is triangle sum. So 110 plus 40, let's see, 110 plus 40 plus this angle is going to equal 180. So I'm going to add these two together. 150 plus x is 180. Subtract 150 from each side. So x is 30. Alrighty. Number 12, we've got, do you remember what these are called? Here's your circle. 360 for the full circle. Do you remember what angles that are across from each other are called? You probably know they're congruent. They are. They are called vertical angles. So vertical angles are congruent. So we know 8k plus 9 is going to be equal to 9k plus 3. We've got x's on both sides. Let's get rid of the smaller one. Not x's, k's on both sides. So 9 equals 1k plus 3. Subtract 3 from each side, so k is 6. There's one just like that on the test. There's one like this, and there's one, let's see. There's one like number 4 from the last homework assignment. And there's others that I'm just not thinking of off the top of my head. But if those were difficult for you, go back, review them. Don't just say, oh, I didn't really get that, and move on to the next one. Take some time and make sense of it. Okay, this triangle is equilateral. That means all the, do you remember what that means? All sides equal. So that means that if this is 3n minus 1, this is 3n minus 1. And so is this entire side 3n minus 1 from here to here. So we are not going to get anywhere if we just say 3n minus 1 equals 3n minus 1 equals 3n minus 1. We're going to have to use this little relationship right here. So if this is something we haven't done yet, if it's an equilateral triangle, it's also isosceles. And in an isosceles triangle, this is called, if it's got a right angle right here, it's the altitude. The altitude is the height, is also the angle bisector. It divides this angle in half. And it's also the median. So I know that this piece right here is also going to be n plus 4. Not something huge, but you might see it at some point this year. So that means that 3n minus 1 is going to be equal to this entire length, which would be n plus 4 plus n plus 4. So that, I wouldn't stress if that didn't make sense, but it's good for you to see it. It could come up on a test. It might be on another test. So n plus n, 2n plus 8. N's on both sides, get rid of the smaller one, so that's going to be n minus 1 equals 8. Add 1 to both sides, n equals 9. Don't worry about that too much if that was a tough one. So here we are given a parallelogram. Now we have not learned all the facts about parallelograms, but many of you will guess and guess correctly that these two angles are equal. I'm going to show you why, because I think I'm remembering correctly that you have to prove this at some point. So you've got parallel lines here cut by 2 transversals. You can also look at it this way. You've got parallel lines here cut by 2 transversals. So let's kind of, let's focus on this side. So I'm going to draw my circles. I know that if these 2 lines are parallel, these 4 angles are going to match these 4 angles. So I know that this angle here is going to be the same as this angle right here. And let's see, I'm just trying to think if there's an easier way to do this. There's other ways to do this, but I'm just kind of going through it one step at a time. I don't want to throw too much at you. So then I'm going to rotate my paper and look at these 2 parallel lines cut by this transversal. So if these 2 lines here are parallel, let's draw our circle. I know that this angle, the one that I have an expression for, is going to be equal to this angle. Those are alternate interior angles. So the first set of, let's go back here, the first set of angles that I highlighted, do you remember what those are called? Those are corresponding angles. And I want to get the parallel piece in here. So if parallel lines are cut by a transversal, corresponding angles are congruent. So that's these 2 angles here. These are corresponding. Then if we look at it with this orientation, we've got parallel lines cut by a transversal. These are alternate interior angles, and they would be congruent. So let's put corresponding angles. Let's see. Let's put corresponding angles and alternate, sorry, hopefully you're using pencil, alternate interior angles are congruent. So that means that 7t plus 7 equals 9t minus 11. So let's get rid of 7t, subtract it from both sides. That's going to give me 2t on this side. I'm going to go ahead and add 11 to both sides. So that's going to give me 18, and then I'm going to divide by 2, so t equals 9. And again, I know I'm going fast here. Slow it down, pause it, do what you need to do, review it. These are great problems to practice with for our upcoming test, in addition to the study guide. Okay, number 16, we've got an isosceles triangle, and we know that these, I mean, it's just, these are the markings to show that these are congruent. So we would just say congruent sides. 6k plus 3 equals 3k plus 18. I'm going to subtract 3k from each side. That's going to give me 3k on this side. Subtract 3 from both sides. That's going to give me, 15. Divide by 3, so k equals 5. And I know I'm doing that part really fast. You can slow it down and write it out step by step if you need to. 17, we have 3 angles that are congruent, and we have the measure of the larger angle. Well, if this is m, and this is m, so I have these 3 together would be 3m is equal to, this entire angle expression is 5m minus 28. Let's just put for the relationship congruent angles. M's on both sides. I'm still going to get rid of the smaller one here. So take away 3m from both sides. This looks a little different because you don't have another constant over here. That's going to give me 0 equals 2m minus 28. add 28 to both sides, divide by 2, so m is 14. I'm trying to get this done so I can go to a meditation service tonight, so I'm kind of going fast. I know. Number 18, we've got parallel lines. I'm going to rotate my paper this way. Parallel lines cut by a transversal. So I know that these two angles, you remember the relationship there? Those are same side interior angle. You can do the tracing, trace this one and slide it down. It'll make a half circle. So let's start there because I see these both have the variable x and this has the variable y. So I'm not going to be able to do anything with these two expressions. I'm going to have to figure out what this is first. So I know that these add up to 180 and these are called same side interior angles, and they are supplementary. So 7x minus 19 plus 3x plus 14 equals 180. Let's solve for x. That's going to be 10x minus 5 equals 180. I'm combining like terms. Add 5 to both sides. So then x is going to be, divide by 10, that's going to be 18.5. So I'm going to have to plug that in because I need to know what that angle is. So let's see, 7 times 18.5 minus 19 is 110.5. So this angle is 110.5. And then these two angles are, what are these called? Vertical angles. Vertical angles are congruent. So that means 5y minus 2 equals 110.5. Add 2 to both sides. Divide by 5. So y equals 112. 22.5. Okay, number 18. We've got an isosceles triangle and we've got an exterior angle. So the exterior equals the sum of the remote interior angles. So that means this angle is equal to these two together. So if this is x plus 4, this is an isosceles triangle, my base angles are going to be equal, then this would be x plus 4. So that means these two together equal 134. So let's just go ahead and combine like terms. That's going to be 2x plus 8 equals 134. And then subtract 8 from each side. So 2x equals 126. Divide by 2, so x equals 63. Parallel lines cut by a transversal. These two angles are, do you recognize them? Those are corresponding angles. So let's put if parallel lines, I know I'm making you write this every time, are cut by a transversal, because I want you to remember it, corresponding angles are congruent. You could do the tracing paper, trace this, slide it down. It's going to be the same as this one. Oh, here comes the rain. So 3x plus 7 is going to be equal to x plus 35. I'm going to get rid of this x, subtract x from each side. It's going to give me 2x on this side. Subtract 7 from both sides, so that's going to give me 28. divide by 2, so x is going to be 14.